So this video is going to continue Chapter 7 of Geometry. It's going to cover 7.4 through 7.7, and by the end of this video you should know several new conjectures about circles and arcs. So we're going to start with the inscribed angle conjecture, which says that the measure of an inscribed angle in a circle is 1/2 the measure of the central angle. So if we have our circle, and if we have two chords that form an inscribed angle, and we have the center of our circle here, and we have the two radii that form a central angle that connects to the same 2 points. And basically what they're saying is this angle is going to be exactly 1/2 of this angle. So essentially this is because this angle starts at the far end of the circle and this starts halfway through. So the next conjecture says that the opposite angles of a quadrilateral inscribed in a circle are supplementary. So we can easily see this if we draw a circle and then inscribe a square, because obviously the opposite angles, which are both 90, are going to be supplementary. But even if we try a slightly more irregular quadrilateral, say something like this, you would still see that, so this is an obtuse angle, this is an acute, and they're going to end up being supplementary. So this next one's pretty logical. If we have a circle, and we have two congruent arcs, so we have an arc from here to here, then points here and here, we have an arc from here to here that's the same size, then points here to here, then the two lines connecting these 2 points, and these 2 points are going to be parallel. So the circumference of a circle is going to be the distance all the way around the circle, from here, going all the way around back to here. And the circumference conjecture says that if C is the circumference and D is the diameter of the circle, which is this line here, then there's a number pi such that C equals pi d. And because d equals 2r, there are two radiuses in a diameter, where r is the radius, then c equals 2 pi r. So these are your formulas to find the circumference of a circle. You have c equals pi d, so pi times the diameter, and c equals 2 pi r. So c equals 2 pi times the radius. And pi is approximately 3.14. So, for example, if we're given a circle that has a diameter of 3 meters, and we're asked to find the circumference, then, so we know our formula is going to be c equals pi d, because we're given the diameter, and then, so c equals pi, and then we can plug in our value, 3. And then most calculators will have a button for pi, so I'm going to use that. And then, but you can also just use 3.14 and get a pretty accurate answer. And we're going to get 9.42 meters, approximately. And then there's another type of problem that maybe you'll receive the information that the circumference of this circle is 12 pi meters, and be asked to find the radius. So here we can still use the same the other formula, so 2 pi r equals the circumference, and then you plug in what you know. So we know that 12 pi is the circumference, equals 2 pi r, and then we can divide each side by 2 pi to get r equals 6 meters. So to find the length of an arc, also called arc length, you take some fraction of the circumference of its circle. So because essentially an arc is a fraction of the circumference, the whole length around. So for example, if we have a semicircle as an arc, that's going to be 1/2 of the circumference. And then we have our arc length conjecture, which says that the length of an arc equals the circumference times the measure of the central angle, so that's the angle, sorry, that's the wrong center, but from here to here, divided by 360. So essentially your formula is we have length equals the circumference times the measure of the central angle, so whatever we can call this A, divided by 360. So you need two different types of information to solve this problem.